Hi, Mr. Corsi here. Here's a question that involves a line. We're given its equation and we're asked to determine the angle the line makes with the positive direction of the x-axis. So there's a basic result about lines crossing the x-axis. When they make an angle of theta, if you imagine a right angle triangle, the tangent of that angle is opposite over adjacent, and distance up divided by distance along. So the gradient of this line is actually the same as the tangent of the angle that it makes with the positive direction of the x-axis. I mean, there is the case where a line comes down and has a negative gradient. I mean, this result still holds. Remember that the tan of an angle in the second quadrant is negative. Only the sine is positive for second quadrant angles. So there we have this, both possible situations, but the connection is that the gradient of this line will be the same as the tan of the angle that it makes with the positive direction of the x-axis. So our first task is to find what the gradient of this line is. And therefore we'll have to reformulate this equation and write it in a form where we can just read off the gradient. So that would be involving y on its own. So let's add root 3x and subtract 5 from both sides. So we'll end up with root 3x minus 5. And therefore, the gradient of this line is root 3. So, if the required angle is theta, then the tangent of that required angle will be root 3. So now remember, we're in paper 1 with no calculator, so how on earth do we find an angle whose tangent is root 3? Well, the root 3 is the clue to this. I mean, remember, for exact values, we either deal with squares, half of squares, which would give us 45-degree angles and 1/1s and root 2s, or in this case, we use an equilateral triangle and chop it in half, and that gives us 30 degrees and 60 degrees. The sides of this equilateral triangle are side 2, so chopped in half that would be 1, and Pythagoras' theorem in this 2 squared minus 1 squared square rooted would give us root 3 for that third side. So the tangent opposite over adjacent is a 60-degree angle whose tan is root 3 over 1. So we're talking 60 degrees here, or pi upon 3, a third of 180 degrees, pi upon 3. And I haven't put degree signs in here, so let's just use that, pi upon 3. And that's the only one. Remember, solving an equation like tan being positive, we would get the tan being positive in the first and the third quadrants. But angles of straight lines with a positive direction of the x-axis can only be between 0 and 180. We can't go beyond 180. So pi upon 3, or 60 degrees, would be the answer to this question. So that's Mr. Corsi signing out, and thanks for watching this video.